So now in this video we got 5 series LEDs, but only 5 volts at the power supply. So I made a simple DIY voltage booster here. This is not an effective circuit. You can just buy voltage boosters, probably for the same price as it would take to make it, you know, if you made one really efficiently. But yeah, the LEDs are glowing, but may not be able to tell even though the lamp's at the dimmest setting. And there we go. Now you can see them glowing right there. So you would need, you know, about 15 volts to really get them to glow well. We got a 1000 ohm resistor right there limiting the current, and the voltage across them is being stored in the capacitor. But yeah, in any case, we'll kind of look at the pocket oscilloscope. Each square going up is 2 volts, 2 volts per division, and there you can see it rising. So there's about 11 volts right there, and if I got up to the line up there, it would be 12 volts. So we're falling between about 11 and 12 volts. So now here's a quick look at the schematic diagram I put together. It's a lot bigger, but we got a voltage booster circuit here. We got 5 series green LEDs, 1000 ohm resistor. We're going to need, you know, 15 volts to really light it up brightly, but we're going to fall short of that. So we got a capacitor, only 5 volts at the supply. That's the main thing. So we need to get current flowing through the inductor, transistor on, transistor turns off. That current briefly flows into the capacitor, raising its voltage. Pretty straightforward. And now, when it comes to the timing for how long the pulse is high, we have the timing circuit there. Now, I'm doing this manually, so we have to make sure we just give brief pulses to the trigger pin, much quicker than I can press and release it. That's the main thing. So we got this little capacitor there. Right when I close the switch, we get a quick pulse, but then the capacitor charge, and it stops that pulse until I remove the button and it discharges. So now we're going to explain part of this circuit a little slower. We got 5 series green LEDs right there. We would really need 15 volts to light them up pretty well. 1000 ohm resistor, limiting the current after that point. The voltage across them is going to be the same voltage as the capacitor right there. Of course, this circuit's going to discharge the capacitor over time. Now, to get higher than the 5 volts there, we need to get current flowing through the inductor and then get the current flowing into the capacitor by turning the transistor on and off, basically, right there. And so that's as far as we're going to look so far. We got the capacitor there, our load there, and the diode so that the capacitor charges but not come back that way right there. And then the inductor. This is not the best inductor to use, but it works for our demonstration circuit. And there's the transistor. When it's on, the inductor conducts. Turn the transistor off, you get a quick pulse of current into the capacitor. So now, we need quick pulses of current into the capacitor to raise the voltage enough to get the LEDs to start lighting up, you know, about 11 volts or so before they even start glowing a little bit, which is kind of the limit of this circuit. But in any case, we're doing that by turning the transistor on and off to get current flowing through the inductor and then off to get it to pump it into the capacitor. 1K resistor because we kind of need a lot of current. So in any case, we have timing set, so we want really brief high pulses, so we got this capacitor and resistor there, low values. And since I'm doing this manually, which is a terrible way to do it, but it's good for demonstration, I don't want a low input to pin 2 for long periods of time when I hold the switch down right there. So I got a little capacitor to interrupt that. So now we looked at this on the schematic in the previous short, but there, we need about 15 volts, you know, to really get that to light up. You know, at 11 volts, we'll get a little bit of glow, kind of limit of this circuit. Transistor gets current going through the inductor and then turns off. That pumps that current into the capacitor to raise this voltage. So we got a 1000 ohm resistor because we need a fair amount of base current to the 555 timer. It's in monostable mode. You can see that wiring right there. That resistor and that capacitor. This resistor is doing nothing. I should have removed it. But in any case, we have the trigger pin right there. We need, since I'm doing this manually, which is a terrible way to do it, but it's good for demonstration. You can sense the pulses every time I press the button. We got a little capacitor there. So when I press the button, we briefly get a short and low voltage, and that triggers it. But then the capacitor quickly charges and stops triggering even if I hold the button. So now, the inductor I'm using for this voltage booster circuit, don't try to actually build this for series circuits, just buy a voltage booster module. But in case, it's a 10 millihenry inductor, and it actually has about 25 ohms of resistance. So when I short it to ground through the transistor when it's on, it does still limit current a fair amount. But you get quite a bit of current flowing through there. Turn the transistor off, it pumps into the capacitor, raises its voltage. So we just wired the 555 in monostable mode, and I got a, I'm doing it manually, terrible way to do it, but to limit the pulses to the trigger pin, the low pulses, I got a capacitor. But yeah, there you can see that right there. It's one of these. Again, it's not the best inductor for this. Just buy a module if you actually need one. But these were a relatively low price with a fair amount of inductance. But it also has a fair amount of resistance for an inductor right there. And you can see the setup right there. So in any case, that's all I'm going to go over for this circuit. Hope you enjoyed.